Alright, video 3 on difference equations. There are some typical questions that are asked in the calculation questions. Things like find the steady state value, find the value after a particular time or a particular number of iterations of the difference equation, or find the time to reach or exceed a particular value. And these are just some examples of those questions. So 12C question 3 we're starting with. And the question gives you u of n is equal to a half u of n minus 1 plus 16, where u of 1 is equal to 128. Again, I know that I'm going to need two numerical values for that. So I found u of 2 by getting u of 2 is equal to a half of u of 1 plus 16. That's u of 2 is equal to half of 128 plus 16, so it gives me 70. My general solution in the first line, and then I just take the multiple in front of the u of n minus 1 and put that in for my k value. Now question 3 does say solve the difference equation, so we go through the steps that we had already. I start with u of 1 by putting 1 in instead of n in my general solution, and I know u of 1 is equal to 128, so that gives me the first formula. I then go on to u of 2, because I know u of 2 is 70, put a 2 in instead of n in the general solution, and that gives me the second equation. Solve the simultaneous equations for a and b, and then we get a general solution here. Now, before we go on to anything else, just to clarify what the u of n stands for and what the n stands for. The u of n is the value, the amount, so that's a number, it could be any number, and the n itself is the number of iterations that we're going through, or the number of terms we're at in the sequence. So in this case, we started at u of 1, so n equals 1 is the first term, n equals 2 is the second, n equals 3 is the third, and so on and so forth. And just for completion's sake, if we go back to the top box, where it says u of 1 is equal to 128, 1 stands for the first term, and then the 128 is the value of the first term. U of 2 is equal to 70, that's telling us the second term has a value of 70. So with that in mind then, the part B says find the seventh term in the sequence. So we started with u of 1 being the first term, the seventh term in that case is u of 7. So basically we put n equals 7 into the equation. The power there is n minus 1, so that's 7 minus 1, which is 6, and you can just work that out yourself in the calculator. That should be fairly straightforward. Part C then. Part C looks for the limit as n goes to infinity of u of n. That's called or referred to as the steady state value. It's the value that the sequence will tend to as time goes to infinity. So a sequence might hop between certain numbers. It might go 0, 4, 1, 3, and then go 2, 2, 2, 2, 2, 2, 2, and continue going towards 2. That value that it tends towards, or the value that the sequence will settle at as the number of terms goes to infinity, that's called the steady state value. So how do we find the steady state value? Well, in the question it says the limit as n goes to infinity, so all we do is put infinity in instead of n. So u of infinity will work out as 116 half to the power of infinity minus 1, which is just infinity plus 12, and any fraction to the power of infinity works out as 0. So it's 116 by 0 plus 12. Okay, question 5. Let's have a look at a few of these. So question 5 says solve the difference equation with u of 1 is equal to 80. Again, I know there's going to be an a and a b in it, so I need a u of 2 as well. So my first term is a value of 80, my second term is a value of 100. I then know that I need two equations. I need to solve the equations for a and b, and that gives me my solution. That's the first part. Now, with that question, we are asked for the 10th term, which should be straightforward. The first term is u of 1, so the 10th term would be u of 10. We're asked in part D for the steady state value. That should be straightforward as well. Let n equals infinity, and you should get minus 80 multiplied by 0 plus 160. So the answer should be 160. And then the final thing that I'm looking to do is find which term in the sequence is the first to be greater than 140. So that's what we want to focus on here. So if the first term is greater than 140, we're looking for the n value that the u of n is greater than 140. And the u of n there we have on the top box with the red outline in it. It's minus 80 by that thing in brackets plus 160. So I'm going to leave that greater than 140, and I'm just going to do a bit of algebra, maths, and you will see a few tricks here as well to get a value for n. So the first line, we let it equal to, or let it greater than 140. I brought the plus 160 over. That gets us to the second line, and then I divide by minus 80. And the first trick there is when you divide by a negative number, it swaps the direction of the inequality. So the greater than becomes a less than. Now there's an issue here in that we have a power, and n is in the power, so the only way to get the n out of the power is take the log of both sides. I'm going to take the natural log of both sides. So the natural log of 3 to the power of n minus 1 is less than the natural log of a quarter. That means we can take the power out now. So n minus 1 is the power, that goes in front, and we get n minus 1 bracket natural log of 3 is less than. Now, natural log of 1 over 4 is the natural log of 4 to the minus 1, and that minus 1 comes out in front as well, which is where that minus natural log of 4 comes from. All we now need to do is solve for n. So I need to divide by the natural log of 3. I need to bring across the minus 1, it becomes plus 1, and you can work that out numerically yourself. All right, a few questions for you guys.